Indices and laws. Indices do have laws. So let's break that down in today's video.
Master Math with Addy.
When we have an index like this, we have to know what these are. So you have to know this x is the base and that is the index or exponent. Now, when we're talking about indices, we have different laws which we should maintain in indices and which can help us solve indices. So we have about 5 laws. So let's start with law number 1. So law number 1 states if we have two exponents, so an exponent is the same as the index. So if we have not exponent, but I mean indices. So if we have two indices which have the same base, then their powers are going to be added to each other. So as you can see here, if they're being multiplied by the two, the powers are being added. So it's going to be a to the power m plus n. So that's our law number 1. Law number 2 states, so if we have two indices which are being divided by each other and they have the same base, then their powers are going to be subtracted from each other. So these two indices have the same base, so their powers m and n are being subtracted, which is giving us a to the power m minus n. So that's our law number 2. Now law number 3. So the third law, if we are multiplying an index by a power outside the brackets, then we're just simply going to multiply the in power with the outer power. So if we have something like a, b, and then we say to the power 6. So this 6 is for everything. So it's a to the power 6, b to the power 6, b to the power 6. Not just b alone, but everything in the bracket. So like here, m minus n. So that is our third law. So number 4 is the inverse law. So we have a inverse, or a to the power negative 1. So this is just the same as 1 over a to the power 1. Now we know anything to the power 1 is just itself. So 1 over a. So that is what the fourth law states. So for example, if we have 2a to the power, maybe say negative 2. So this is the same as 2 times a to the power negative 2. So this only implies to the a. So it's going to be, let me just erase this. So it's going to be 2 times, so you're going to say 1 over a to the power 2. So that is what we mean. So you can simply write this as 2 over a to the power 2. It's still the same thing. Now when we come to our fifth law, so our fifth law states any base which is raised to the power of 0 is always equal to 1. That is the fifth rule. So for example, in the second rule, when we said when you're dividing indices with the same base, we're going to subtract the powers. So for example, let's say we have a to the power of m divided by a to the power of m. So what do we do here? We say a to the power m minus m, which is a to the power 0. Now, this statement can be written as a to the power of m over a to the power of m. You know that, right? Because if we say m minus m, it will give us a to the power 0. So what is a to the power m into a to the power m? 1. So this would give us that. That is why we say any number raised to the power of 0 is 1. So now let's look at fractional indices. So we have a to the power p over q. So when we're looking at fractional indices, you have to know that the denominator of the fraction of the raised power is the root of the index. And then the numerator is going to be the overall power. So what I'm saying is q is the root. So we're just going to say the q root of a. And then this will be raised to the power of p. That is what I mean. So a valid example is this one. We have a to the power negative 2 over 3. So this one is going to be, the root is 3, so cube root of 8. And then we're going to raise this to the power of negative 2. So the cube root of 8 is what? 2 to the power negative 2. Okay, so remember what we said about inverse, the inverse rule? It's going to be 1 over 2 to the power of 2. So it's going to be 1 over 2 times 2 is 4. So our answer is a quarter, or 1 over 4. So let's have this question. Simplify this thing over here. So before we solve this question, if you are having any value in today's work and everything you have been watching on my channel, don't forget to subscribe and like and comment and share it with others. So let's continue. So we have the quadruple root of 3a times 9 to the power a plus 1 over 27 to the power a plus 2. So the first thing you have to always think about is making the bases of all the indices equal. So we have 3 over here. So let's forget about the root over there first. So let's say 3a times, so 9. So if we change 9 to the base of 3, what is it going to be? It's going to be 3 times 3, because 3 times 3 will give us 9. So we're going to say 3 to the power. So you have to take this same power over there. Yeah, so since we said 3 times 3, now instead of us writing 3 times 3, we can just say 3 squared, because 3 squared is 3 times 3. So we put 3 squared over there. Then we get that power, a plus 1. And do this, a plus 1. And then over, for 27, what is it? 3 to the power 3, because 3 times 3 times 3 will give us 27. So we'll do the same thing, a plus 2. Okay, now we can just simply multiply this with that. So now what we're going to do is we're going to multiply this. So let me multiply it on the same question so we can utilize the space. So 2 times a will be 2a plus 2 times that will be 2. Then here to be 3a plus 3 times 2, 6. So these are the powers of the 3 over there. So now, what do you see? The rule, the first rule states if the bases are the same, then you add the powers. So what are we going to do? So for the first top part, we're going to say 3 to the power a plus 2a plus 2. Okay? And then a plus 2a is what? 3a. So it's going to be 3 to the power 3a plus 2. So now we know this is over that. So we're dividing, so we just subtract. So let's do this. It's going to be 3a plus 2. We'll do that, minus the bottom part. So we're going to say 3a plus 2 minus 3a minus 6. Then 3a and that 3a, they're like, so they'll cancel. So 2 minus that, it will be 2 minus 6, which is negative 4. So it's going to be 3 to the power of negative 4. Okay, so inverse, so it's going to be 1 over 3 to the power of 4. So 1 over 3 to the power of 4 is 81. We're not done. Remember, I said do not forget the root. So we're going to say the quarter root or quadruple root, whatever you want to call it, of 1 over 81. So we know the fourth root of 1 is 1. And then of 81, it's going to be 3. So our answer is 1 over 3. So you can write in the comments what you call when you're finding the fourth root. I don't know if it's fourth root, quadruple root. You can type it in the comments so you can help me know. So that is our answer. And you can check these out other videos which can help you in math, and I'll see you in the next video.